Okay guys, hope you're having a good weekend. Today we're going to be looking at section 3.2 again, but the second part of it. So let's look at 3.2. Let's get on the top of our paper, 3.2 notes. Okay, and let's make sure we put the date. Alright, so today we're going to be talking again about systems of equations. Are you bored yet? No, you're not. We're going to look at the final way to solve a system of equations. And you did do this in Algebra 1, so I'm hopeful that this is going to come back to you. The book calls this method the linear combination method. You'll also see, and you'll hear me say, the elimination method. The reason I call it elimination is because you're actually trying to eliminate a variable. But the basics are you're going to be combining the equations together. So this is unlike substitution. And the reason we would use this would be an example like I gave you. 2x minus 4y equals 13, and 4x minus 5y equals 8. I told you that usually with substitution, you want to look for one of the variables that has a coefficient of 1. This one does not. So sometimes it might be better to use combination so you don't get involved in having fractions or something like that. How do you use the linear combination? Well, you have to look at each variable and you need to make either the x's or the y's, they need to have the same coefficient but different signs. So you have to decide which one you're going to turn into the other. So I looked at this and I said, okay, 2x and 4x, I like that they're both divisible by 2 and I know that I could make this 4. But so I'm going to go ahead and do that. Now I also want them to have opposite signs. This is one way of thinking about it. So I'm going to multiply the top equation, the entire equation, by -2. All right, and for me to do that, what I'm going to do is I'm going to keep that whole equation in red. I'm going to actually do the work down here so that it's right under the other equation. So I multiply -2 to everything inside it. I'm changing it. I'm just kind of making it bigger. So now I have -4x plus 8y equals -26. So I basically just distributed that -2 to everything. So I'm going to do to everything, I'm allowed to do that. So then I'm going to combine. I'm going to do the combination. I'm going to combine them using addition. I'm going to add the equations together. So I have 4x minus 4x, that's going to get eliminated. -5y plus 8y is going to give me a positive 3y. And then 8 plus -26 is going to give me a -18. Then I'm going to divide by 3, and I'm going to get y equals -6. All right, but I'm not finished, because I know that you remember from the last 3 days we've been working on this that the solution to a linear system is a coordinate point. We only have the y, so we have to find the x. So what you do is you take your y and you plug it into either of these two equations, it doesn't matter, and solve for x. I'm going to actually just plug it into the first one. So I'm going to get some room here. 2x minus 4 times -6, again when I plug it in I'm going to go ahead and put it in parentheses, equals 13. Alright, so then I've got 2x, -4 times -6 gives me plus 24 equals 13. Alright, I'm going to subtract 24 from both sides. And I'm going to get 2x equals, what is that, -9? 11. 11, sorry. -11. Okay? And then I'm going to divide by 2. So x is going to be equal to -11 halves, which is -5.5. So I'm going to write that as -5.5. All right, so then I can go ahead and write that as a coordinate point, -5.5, comma 6. Now, I want you guys to, I'm going to go ahead and, like I did yesterday, I want you to see the steps we just went through. So the first thing we did is we multiplied 1, but it could also be both equations by a number to obtain coefficients that differ only in sign for one of the variables. Then we added the revised equations. This eliminated one of the variables, and we solved for the remaining variables. And then step 3, we substituted the value from step 2 into the revised equation from step 1. and we solved for that missing variable. So I'm going to give you guys a second to write those down because I know some of you actually really like having your step-by-step model there for you, okay? All right, now let's move on. Oh, and I forgot, I just noticed I had -6. This should be a -6 down here for this answer. So make sure you make that change. Sorry about that. All right, let's go on to our next example. All right, this is where a linear combination gets a little bit more challenging. Sometimes you have to multiply both equations by a number to make either the x's or the y's the same, okay? So I looked at this, and you might have seen something different, but I decided that I'm going to change the y's since they are already opposite signs. I'm going to make them both the same number. So I'm looking for their lowest common, their GCF, their greatest common factor, or their lowest common denominator. Lowest common number that they both go into, sorry. So I'm going to make them both 24, because 24 is the number that they both go into. So I'm going to make this 24 by multiplying the entire equation by 2. And this entire equation, I'm going to make it this 24 by multiplying it by 3. All right, so it starts to get messy. You have to be really, really neat. So I'm going to bring this equation down here, and I'm going to bring this equation down here. So I'm going to get 14x minus 24y equals -44. Don't forget to distribute that 2 down here to that -22. All right, then I'm going to do the bottom equation. I'm going to do it in a different color. 3 times -15, or -5 is -15x. 3 times 8 is 24, which is what we wanted. We wanted both the y's to be the same number, but opposite signs. And then 3 times 12 is going to give me 36. All right, then we combine them by addition. We add the equations together. So we have 14 minus 15x, which is going to give me a -x. These are going to both get eliminated, okay? And then we have 44, a -44 plus 36, which is going to give me a -8. All right, we're going to divide by -1, so then x equals 8. All right, now we're not quite finished. So now what do we have to do? We have to take that value and we have to plug it into one of the equations. Doesn't really matter which one. I'm going to actually plug it into this equation just because I can see it clearly. And so let me move my screen up a little bit, like right there, so you can see. So I've got -5 times 8, I put it in parentheses, plus 8y equals 12. And, okay, so we get -40 plus 8y equals 12. I'm sorry, add 40 to the other side. Okay, keep going, do the math. We get 8y equals 52. We divide both sides by 8. Okay. All right, and we're going to get y equals, 8 goes into 52, what? 6 times, and you're left with 4. So 6 and 4/8, is that right? Yeah, 6 and 4/8, which I would write as 6.5. Okay. All right, so then I write my coordinate point, my answer, which would be 8, 6.5, and there is my solution to my system of equations. Hopefully you're feeling pretty good about this. All right, so let's look at another example. I want you guys to remember that we still, no matter what, can still have many different answers. We can have one solution, which means one point of intersection. Okay? We can have infinitely many solutions. It means it is the same line. And yesterday I said that the lines then coincide. Coincidental lines. And then no solutions means the lines do not intersect, so it means that we have some type of parallel lines. Okay, all right, but now I want you to practice and I want you to feel comfortable with this because I've done both the examples. So I want you to solve this system of equations. You try it. -6x plus 5y equals 4 and 7x minus 10y equals -8. So I'm going to ask you to press pause, try it, and then come back and watch what I did and see if you did the work correctly. So I'm waiting for you to press pause. Go ahead, press pause. Okay, all right, so now you're back, and I look at this equation and I see that 5 and that 10 so nicely. We want to make them the opposite, same number in front, but opposite signs, and they are already opposite signs. So I can just make the top equation positive 10 by multiplying everything by 2. All right, I'm going to rewrite that equation. I'm going to bring it down below it just so it's nice and neat for me. So I get negative 12x plus 10y equals 8. All right, let's see what happens. We keep going. We add the equations together. So we have 7x minus 12x, which is going to give me negative 5x. Okay? We see that 10 and 10 are going to get eliminated. We have negative 8 plus positive 8, which equals 0. That's still okay. We're going to divide by negative 5. So we get x equals 0. 0 over negative 5 just gives me 0. All right, so now I've got to solve for my y. I take my x, I plug it into either equation. So I'm going to go ahead and plug it into the first one. So I have negative 6 times 0 plus 5y equals 4. That will cancel to 0, so I have 5y equals 4, and then I divide by 5. So y should have equaled 4/5. Okay, so hopefully you felt pretty good about that one. Let's go on to one more, and then we'll be finished. Okay, so now what I want you guys to do is I want you to write down this equation in your notes. 7x minus 4y equals negative 3, and 2x plus 5y equals negative 7. Actually, I'll put that full screen so you can see it a little bit better. There you go. All right, so now the video is going to end at this point, but what I want you to do is I want you to try this on your own using linear combination, and I want you to bring your answer into class, and we'll check to make sure you all feel comfortable with it, okay? So I will go over this problem in class tomorrow, okay? So hopefully you guys feel more comfortable with linear combination. We will be practicing all 3 methods tomorrow in class, and I will see you then. Okay, bye-bye.